Hello and welcome to this Technology Primer brought to you by North Border Software. My name is Gary. This is the first part of a two-part series looking at the OSI 7-layer model. So those of you wanting to get a start in data networking, the Open Systems Interconnection 7-layer model is a really good place to start. It's a conceptual model that's been around since the 1970s, and it's really done good service since then. It's as relevant now as it was back in those times as well. It was designed really to promote standardization within the industry by splitting the network into modules. It's easier to develop individual technologies to satisfy those modules and make them interchangeable as well. For instance, if we look at IP at layer 3, that will work just as well over Ethernet at layer 2 as it would do with PPP at layer 2, and in turn Ethernet can work over a variety of physical media, from fiber optics to copper cabling. So this interchangeability allows for a much more scalable and easily manageable environment compared to something that would be homogeneous down from layers 1 to 7 developed by individual manufacturers. That technique probably wouldn't be scalable, it would be hard to maintain, and it'll really lock you into proprietary vendor systems. So having standardization has really allowed us to grow the internet in the way it has today. So if you look at layer 1, this is concerned purely with the physical media. There's no intelligence at layer 1, it's really about the cabling itself. And some of these serial protocols you might find, something like RS232, X21, fiber optic cabling, wave division multiplexing systems, and the copper cabling over which Ethernet runs over, which is Cat5 with RJ45 presentation. So that's really all the physical layers about, it's that physical media. When you move to layer 2, there's a little bit more network intelligence comes here. Layer 2 is really about establishing reliable data link connectivity between adjacent stations. So it's a point-to-point environment. It's not an end-to-end over the network. That data link is established between adjacent devices. So technologies that will satisfy the data link layer are Ethernet, the point-to-point protocol, HDSL and frame relay are really some of the most common ones you'll likely see nowadays. Certainly Ethernet is the predominant technology in this environment now. Moving up to the network layer, layer 3. This is a really interesting layer for those the people who are interested in the routing side of the business. So this is about establishing locations on the network. So like postal addresses, nodes on the network need some form of address to identify them, which needs to be unique. So that's really what the network layer is about. So you'll know the term IP, the Internet Protocol. There are others, the Internet Network Packet Exchange, IPX, but really IP is the predominant protocol there. Now IP and IPX are what we term routed protocols. They define address locations, but in order to get the data from end to end, from source destination through the network, you'll need a routing protocol. So this is where open shortest path first, OSPF, and intermediate system comes into play. These are routing protocols which allow the transfer of data over the network by defining the paths. The transport layer is at layer 4. Things that happen at the transport layer are it's about reliable connectivity. So it's about detecting failures and rectifying those failures and implementing any flow control mechanisms. So this is really the first I guess host to host or source to destination or end to end protocol in the stack. Network layer works at intermediate stations, but transport layer is really between host stations. So things you'll find at layer 4 are the transmission control protocol, TCP, which typically works over ITP, and user datagram protocol as well, UDP. So establishing, the session layer is really about establishing connections. It's about setting up the end-to-end, I guess the transaction, the flow, setting up calls and tear down of calls. This is all done at the session layer. For those like myself who work in the the routing and switching side of things, we seldom get to see anything that goes on at layer 5 and above. But some of the things you'll recognise from maybe setting up some PCs are NetBIOS, NetBIOS, those sort of protocols that work at that sort of layer. Other things that might work at the session layer are maybe the types of flow, whether it's a full duplex or a half duplex, and it's getting that agreement between end stations as to how the transmission is going to occur. The presentation layer, layer 6, is probably conceptually the most hardest one to visualize. It's about taking data from the application and forming that into a way that's ready for transmission over the network. It's about things that may happen at layer 6 are encryption. That's the typical thing that may happen at layer 6. But here we talk about JPEGs and MPEGs formats. It's about how you're going to manipulate that data ready for transmission over the network. So the application layer, this is an interesting layer because I think one of the misconceptions that really occurs is the application is not the application itself which people are using. It's the elements of the application which are responsible for transmission of data over the network. If you look again at the TCP stack, then some of the applications you'll see are the Hypertext Transfer Protocol, HTTP, and that'll be an element of the browser which is responsible for transmission of the data. So file transfer protocol as well. You'll be very familiar with all of these terms. These actually work down to layer 5 as well. So that's really just run through the layers themselves. What I want to do in part 2 is look at how the modern technologies, real technologies, are applied to the OSI stack, so we can go from a conceptual to a real model. There are a few alternatives there, and we'll look at how data actually flows through the stack from top to bottom over the network and back up again. That should give you a basic understanding of what you need to move forward in data networking. So I hope to catch you in part 2. I hope you found this useful, and bye for now.